In this discussion, we're going to discuss some statistical data mining techniques. In particular, we are going to discuss linear regression and also logistic regression. When we talk about regression, we're talking about here making a data mining model where the definition of the model, the concept definition, is a mathematical formula. Many of you are experts on regressions from your statistics classes. So you know that with regression, we create a mathematical formula that can be used to do predictions or to calculate new values. Regression is a supervised learning process or learning techniques. And if we look back to the diagram that we had very early on in this class, we remember that we have supervised learning techniques, unsupervised techniques, including unsupervised clustering, which we have now worked with, and market basket analysis, that is an associated type analysis, where we consider in a market basket sense that has been purchased together. So we're over here in the supervised learning area. Where when we're talking about regression, we're going to train our model with data that we prepared. So with linear regression, it is typical, useful only with numerical inputs and outputs. And the data mining algorithm produces a formula that looks something like this. So here's our formula with an output. The predict value equals to the formula that include the values of input attributes as well as constant values such as A, B, C, and Z. But it does have a form that will yield the formula for the linear output. Obviously, linear regression is most appropriate when the relationship between the data is linear. In general, the trend in the data would be linear, but this may not be known upfront. So you may use linear regression and find out it's not as appropriate as you thought. Simple linear regression involves only one input attribute, but multiple linear regression, which we will be working with within Microsoft toolset, involves several input attributes. Then, of course, something that is being predicted. Logistic regression is similar to linear regression in that it is useful with numerical inputs and outputs. But in this case, the data mining algorithm produces a more complex formula. It still produces a formula. The concept definition is a mathematical formula, but the formula may not be linear in nature. So to summarize a bit, regression is a supervised learning technique. It does require existing training dataset. So that needs to be data that has a predictable attribute already filled in and follows the supervised learning process, which we have discussed. The process is described in the following slides. That is to see, we have to assemble the data. We have to present the data to the supervised learning algorithm, that is the linear regression algorithm. We have to execute the algorithm, create the model, that is create the regression formula. And then we need to evaluate the model. Our evaluation is going to be a little difficult in terms of regression versus the types of classifications or metrics and so on. But we will evaluate the model. Actually, I should say in this class, we are going to evaluate the model only very generally and leave it to the statistics classes to help you evaluate the linear regression models more thoroughly. But then, once we evaluate the model, we find it to be useful. We can use the model to classify, to estimate, or to predict whatever we are trying to figure out. Just to note a couple of things. Regressions can be done with Excel and many other statistical tools. So it's not unique in any way to the Microsoft data mining toolset. Being embedded here in the data mining toolset offers some advantages for integrating the model within other applications. And that's because you can query the model using the data mining extensions language. So it gets that particular flexibility. To summarize it, what we're seeing is that the data mining techniques draw from statistics as well as artificial intelligence as well as database algorithms. We mentioned this early on, but now that we will have a chance to look at the different types of data mining techniques, that particular statement may make a little more sense here. And then with regression, we ask ourselves, why couldn't we use Excel? And as I mentioned, the data mining model offers more flexibility for integration into other applications, such as websites or for predictive applications.